Hey y'all, it's Miss Page here. Remember, Miss Hudson and I are out today, so go ahead and write your name on your paper and we're going to get started. Please make sure you have your Chromebook charged and ready to go. You've got the packet from the sub and you're ready to listen. The worst thing you can do is fast forward this and just copy down the notes. I'm telling you, you are going to be so lost come tomorrow when Miss Hudson comes back to review, I promise. So the whole point of this lesson is to take two triangles that we have already deemed similar. We already know about their sides, we already know about their angles, and we want to see what happens when we connect them. So we need to take a look at a few examples. These are twisted these are twisted triangles or reflected triangles. And the way that I can tell is right here. Do you see that there's 70 degrees right down here in the bottom? And there's 70 degrees right down here in the bottom? It says write a similarity statement for each. I can't write a similarity statement until I know which letter corresponds with what. So I know that B corresponds with E. That also tells me that these triangles are connected, but they've just been reflected. So if they've been reflected, I'm going to say that A, B, C, remember you can write the first triangle in any order that you want. So if 70 is for E and B, I don't really care what A and D are. I just know that they connect. They are corresponding. So D, E corresponds with B, and then C corresponds to itself. Okay, so that's how you can tell if they're reflected. Now, take a look at this one over here. Do you see that M is 80? But there's no 80 here. Guess where 80 is? It's up here in the corner. So actually, guess what has happened is that 80 degrees for M equals C's 80 degrees. These have been what's called twisted. So write that down. These have been twisted. So that means that your T is going to be similar to your A. Your M is going to be similar to your C. And your B, of course, it's corresponding to itself. So those are your triangle similarity statements on two triangles that look exactly alike, but based on where the angles are placed can be reflected or twisted, and that is going to change the way the statement is written. So be really careful about that. Make sure you have that written down. The question says to highlight the corresponding side, so let's go ahead and go back and do that. That's easy. I can highlight this side. Oopsies. And if it's reflected, then that means this one will connect. I can highlight this side and this one. If you need some color pencils, just hop up and grab them. No big deal. Just pause the video and hop up and grab them. All right. Then over here on the twisted one, you'll notice that 21 corresponds with 14 because they're twisted. They're not mirror images of each other, except for the green side. And you know what? I'm going to color coordinate those so that they look exactly like the shape on the other side. So let me go back and color coordinate those. So instead of having red and red at the top, yellow and yellow, and then green and green, now we've got this like twisted look, almost like an X look. So now that I've highlighted those, and you can pause the video at any time if I'm going too fast. Now that I've highlighted those, we need to determine the missing side links, okay? So in order to do that, you just set up your proportions. If you want to know what X is, you set it up. So I'm going to do that right down here. I'm going to say that, whoopsies, let me zoom out just a smidge. I'm going to say that X is proportional to 10, that 6 is proportional to Y, and that 9 is proportional to 12. And of course, this is the one that doesn't have any variables. So I'm going to use that 9 over 12 to solve for X. And of course, 90 minus 12. I'll have to get out my calculator. Let's see. And I think my calculator's about dead. 90 divided by 12. and that gives us, looks like 7.5. Okay, and we do the same thing for y. 6 over y equals 9 over 12. You could write 9 over 12 first if you wanted to. So 6 times 12 is 72, and when you divide that by 9, I'm getting 8. Okay. So we're going to do the same thing over here on the twisted triangle. I see that I have the blue side is 6 proportional to x. The yellow side is 21 proportional to 14. And the green side is y is proportional to 10. Okay? So it looks like this one is the one that we can use to set up our proportions. 21 over 14 equals 6 over x. So 6 times 14, and then of course we're going to divide by 21, and we get 4. We do the same thing for y, so let's set up y. We have 21 over 4 equals y over 10. So 21 times 10, that's 210, and when you divide that by 4, you get a decimal. You get 52.5. 52.5. Okay, so just a quick recap. Sometimes your triangles are connected, as you can see. If they're connected, they're usually reflected or twisted. Check where the angles are located. That's going to tell you how to write the similarity statement. That's also going to tell you how to set up your proportions. That's extremely important because if you don't know how to set up your proportions, that will make you or break you for the correct answer. So I'm going to give you an example question right here. And let's see how you do. I want you to try this one on your own. Highlight the sides that correspond based on those little angle markings and see if you can solve for x. Pause the video, and then when you get done, press play, and I will work the answer for you. Okay, so this is how I've set it up. I went ahead and looked at my angle measures. It looks like that S has 2 markings and N is in the top right-hand corner and it has 2 markings. So this is a twisted triangle. This one has been twisted. So because it's been twisted, I went back and I looked at that little picture up here and I modeled that with my highlight. Okay. And then, of course, I set up my proportion according to my highlighted parts, and then I solved for x. All right, now that we've talked about twisted triangles and reflected triangles that are connected, let's talk about a different type of triangle. So highlight this for me, circle it, bubble it. Sometimes triangles overlap, okay? Sometimes triangles overlap. That means you have a little bitty one, and then you have a big one in the back. So basically like 2 pieces of construction paper cut out into triangles just laid on top of each other. All right, this is how this works. So read the directions with me. It says the triangles below are similar. Because they overlap, you will need to split the triangles apart. Then you can solve for x. So what I've done is I've recreated a small triangle and a large one. And I've taken the number 10 and 4.8, the base of that triangle, and I have duplicated it over here, 10 and 4.8. And then I have taken, notice nothing's on this side right here. And then I've taken the large triangle and I've duplicated it. Notice I just don't have the number 10 and I just don't have x. I actually have both. Because when you're solving for this entire side, you have to take both of these numbers and you have to add them together. So make for sure that you have 10 plus x. And then, of course, the base bottom 12, it, of course, stays the same. So there's nothing different there. So, y'all, it's really that easy. You just split it up. You write your numbers out beside the sides of your triangle. Make sure, of course, you're adding this long side. And then you set up your proportion. And you can set it up side versus side. I really like to set it up triangle versus triangle. It just keeps it nice and clean. So let me explain to you what I mean. I mean 10 over 4.8, that's the first triangle. Or you could have written 4.8 over 10, I don't care. And then, of course, you have to set up your second part of your triangle. So if you started with 10, which is the vertical line, you're going to have to start at the top with 10x, 10 plus x. and then go to the 12 at the bottom. So make sure that you are consistent, okay? This is nothing that you haven't seen before, and this is certainly nothing that you haven't done mathematically before. So all is well basically now. We're just going to cross multiply 10 times 12, and then we're going to cross multiply on the other side 4.8. Remember, that's not 48, 4.8 times 10 plus x. Please make sure that you cross multiply here. You're going to get 120. We're going to get 48x plus 4.8x, not two decimals, one. There we go. And you know what? You are not going to get 48x, just 48. So 120 minus your 48, that's going to subtract your 48 here. That's going to give you, I'm running out of room, that's going to give you 72 equals 4.8. And of course, whoops, I'm trying to scroll down, there we go. And then, of course, you're going to divide by 4.8. And you've probably already done that and are waiting on me to just shut up and move on. And you get 15. 15 equals x. So we did all of that work in overlapping triangle to get that x equals 15. So I've got a couple more examples on the back on the second page, and I'm going to go ahead and flip there now. What I would like for you to do, and it says you try, I would like for you to try these 4 problems on your own. You know they overlap, so go ahead and split them. Pause the video, and if you crash and burn, it's okay. I mean, God, just erase your paper and start again once the video is over. But I'm going to pause. I'm going to freeze it. I'm going to go ahead and put the answers on the paper. So if you don't pause the video, you're fixing to be exposed to all the answers. So go ahead and try them now. All right, I told you were going to see the answers. So here we go. On number 1, it says, the triangles are congruent. I'm sorry, let me back up. The triangles are similar. Solve for G. So I got G was 12. You can pause the video, check out my work. Number 2, I got that N was 1.75. I split the triangles. I didn't write 12. I wrote 12 plus 4 was 16. Made my proportions, got my answer. Number 3, I went ahead and split my triangle, did x and 5, and then x plus 8 and 9 right here. So they gave me a little bit of some distributive work to do, but I got x was 10. And then on number 4, I actually didn't have as much work as I thought. 4 and 6 goes nicely here. And then 10 actually has this long line of a bracket. So 10 is fine. It represents that number. And then, of course, Z. So that was 6.6 repeating. All right, let's flip the page. Here we go. This is basically the heart of the lesson. So I've allowed you to see twisted triangles and overlapping triangles. So today we are going to start talking about 3 different types of similar triangles. You can now verify triangles through angle, side, and then side, angle, side. So side, and side, angle, side are really easy to identify, but angle has like a host of different types. Some are disconnected, some are twisted with parallels. We'll get into those. Some are overlapping with parallels, overlapping without. And then the ones down here at the bottom, they're connected with parallels. This is just a whole nother level of just yuck. But what I want to show you is each one is different. So like this one, you can tell that those 2 angles right there create the angle similarity. They got the right markings in the right place. And then right here, you don't have any markings, but if you'll notice, the title says vertical angles are congruent. We're going to use that word vertical angles because I actually have a set of angles established here and here. And then I'm going to be able to go back in and draw in my vertical angles to prove angle. Okay, again, we know that the triangles are similar. The question is by what method? AA, SSS, or SAS? So you're just taking it one step further. So here's the little clue. Alternate interior angles are congruent. if you see a twisted yet connected kind of bow tie looking triangle and it's got parallel markings, this is what you're going to do. The parallel line, you're going to get a set of angles there, and then you're going to get a set of angles here. And that's it. That's how you prove angle, angle. You've got two angles marked, so you can prove it by angle, angle. So what happens when they overlap? So when they overlap, this is what happens. The angle at the top is congruent unto itself. So I went ahead and marked it for both. And then you can pick and choose whichever angles you want. You can pick M and E, or you could pick N and F. I don't care. Now, I'm a creature of habit, so I always pick these angles. It's just me. And then, of course, right here, you already have two right angles marked. So when you split this triangle, if you want to look at it, when you split this triangle, you have a marking down here. And when you split it again, that's your D, and that's your E, and this is your D, and this is your M. They are the same. Okay, and then the last one, I'm really not, you know what, we're going to hold off on this one till we need to actually get to that one. So let's just hold off on that one for a little bit. All right, so those are the 5 types of angles that you may run across. Side, side, side is easy. You've got 3 different sides, 1, 2, 3. They're all the numbers are there. And then all you have to do is just make for sure. Now I'm writing these as proportions. You can color code the sides if you want to. I'm just making sure that it actually is side, side, side. That means that every one of these have to reduce to be the same number. And if they do, they're similar. And if they're similar, they're side, side, side. Side angle side just means that you've got a side and angle in between the other side. So you've got a side and angle in another side. Kind of makes that big open mouth, and you've got an angle in between. Now what happens? How do we get side, angle, side with an overlapping triangle? Well, check this out. You've got a side here, you've got a side here, and the S is congruent to itself. All right, so let's not get into a bunch of the technical part. Let's just jump right into our second half of our lesson. The question says, determine if each of these are one of these methods. I want you to go ahead and mark out all of, go ahead and mark out all of those, and then write A right there. Those are the only 3 we're going to use. I don't know why the others are there. I can't figure that part out. So, which one does this look like? Do I have 3 sides? Do I have 2 sides and an angle? Or do I have 2 angles? What am I given here? I'm given 3 sides. So I assume that it's side, side, side. Okay? So I'm just going to go ahead and write this over here as a question mark. I'm assuming it is. But here's the thing. You cannot assume that it's side, side, side unless you do the math. So 12 corresponds with 4. You can see that. 9 corresponds with 3. You can see that. And then 15 corresponds with 5. If they all reduce to be the same number, then it is side, side, side. So it looks like we hit the jackpot at reducing. So yes, it is definitely side, side, side. Let me let you in on a secret. If one of those numbers had not been 3, you would have needed to have written not similar. It would have not been SSS. All right, take a look at number 2. What does it look like I'm given? Remember, there's only 3 methods: SSS, SAS, and angle, angle. So what are you given? You're given a side, and an angle marking. So it looks like it's probably going to be SAS, but we have to prove it. How do we prove that? We do the math real quick. We see if our sides are proportional. That reduces to 1/4. That reduces to 1/4. So that's good. Now that our sides are proportional and our angles are in the right place in between the 2 sides, we can officially say that yes, it's side, angle, side. All right, take a look at number 3. Number 3, you're not given any sides, no sides. You're just given 2 angle markings, and they're both in the same place on the other shape. So we can automatically say that this is angle, angle. All right, what about number 4? What are you given? Whoops. Looks like we're given 3 sides. So let's just check them real quick. Still in a highlighter. 6/8. 9/12. And 12/16. Let's just see if they reduce. I think they are going to work out just fine. Let's see. That ends up being, what? 2 goes into 6. 3 times goes into 8 4 times. Let's see. 3 goes into 9. 3 times 12. 4. Yep. Let's see. 4 goes into 12. 3 times into 16. 4. Oh, yeah, that's perfect. So that one's definitely side, side, side. We assumed correctly. I'm going to tell you, if you ever write them down and you never prove the math, you will always get at least 3 or 4 wrong, because I'm going to throw in a bunch of not similars just to see if you're doing the math. Now, I'll tell you, this right here on number 5, this looks like side, angle, side. I mean, it definitely looks like it. The angles are in the right place, so let's just verify our math. And a lot of this stuff you can do on the calculator without having to, write down. But, I mean, it does show me that you're doing your work. I have no idea if these reduce, but I do know that 7 can go into 30. Nope, that's not right. 5 can go into 35 7 times and can go in there 3. And then, let's see, 2 can go into 14 7 times into 6 3. Yep, so that one's correct. And I wrote a 6 and not a 3. All right, so that means we have side, angle, side. So go ahead and write that on your paper. The vacuum cleaner's on. I'm at school and it's super late, and the cleaning people are here. So here we go. Number 6, we'll make this quick. Looks like side, 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 so double check it. Please, please, please double check it. I'm going to go ahead and pause and do this, and then the next page as well. Okay, all right, so it looks like it's going to be side, side, side. Everything worked out okay. Let's go ahead and take a look at the next page. I'm going to let you try these on your own, but I want to let you in on a secret on number 7 real quick. Anytime there's absolutely no sides, there are no angles, you just have this overlapping triangle with these parallels, I want you to go back and look at your cheat sheet. And I want you to remember that I told you that sometimes they overlap and they don't have any angles. That would be this particular example right here. Anytime that this occurs, it's automatically what? Automatically angle, angle. So let's go back to that question. You don't have to do anything but draw in the angles. There's an angle here and 2 angles there. So you can just go ahead and write angle, angle. Okay? You don't have to do any work. So if you see one of those, oh, look, there's 2 more. So that's easy. There's 2 more. Those are both angle, angle, and I'm going to draw those in because Miss Page told me to. 1, 2, 1, 2. And then right here on number 8, I mean, God, that looks like side, side, side. I don't know if there's any on this packet that are not similar. I know for a fact when I make my worksheets, I throw a bunch in there just to check to make sure you're doing the math. But we shall see. We might get lucky and get a not similar. I don't know. It's 8 divided by 6. 4/3. 12 divided by 9. That's going to be 4/3. And then 24 divided by 12. Oh, look at there. 2. So here's the spoiler alert. Because this side right here was not dilated by the correct scale factor of 4/3, that means that this triangle is not similar. So please write that down. Let me repeat myself. Because the sides 24 and 12 were not dilated by a scale factor of 4/3 like all the other sides are, these 2 triangles are not similar. So we finally got to the good one. I always like to find those. All right, let's check this one. I don't know if these are reflected or twisted, so here's what I'm going to do. I'm going to say, hey, this is the big side. This is the biggest number, and that's the biggest number. And this is the smallest number, and that's the smallest number. So it looks like these have been twisted. So we could say 6 over 12 equals 5 over 10. And of course, those both reduce to be 1/2. So here's the deal. You've got two sides, and we've got SSS, SAS, and angle. Well, we definitely don't have any angles in here. We got no angles. So it's safe to say that you can basically mark that one out. We've got two sides. So it's either going to be this one or it's going to be this one. But here's the catch. You got to have three sides to be side, side, side. So you could mark that one out because you don't have three sides, and you certainly cannot make up a third side. So then we're left with side, angle, side. And you're like, oh, I'll mark it and move on. But here's the deal. You got to come up with this angle in the middle of the two sides. And remember, I told you you can use the vertical angles. If you need it, you can draw them. So that will give you 10. That will give you side, angle, side. And then on this triangle side, angle, side. Last one, and I hope to God we're done. Let me see. Are we done after that? Yes, thank God. This is the last one. Y'all just hang in there. We're almost finished, okay? I'm missing y'all like crazy, and I hate doing these videos because I'd much rather be with you, but y'all just hang in there. We have an overlapping triangle, and we talked about this morning. When you have overlapping triangles, what do? You split them. So let's split them up real quick. Let's do 8 and 6. Those are those numbers right there. And then let's do the big triangle. The whole side length is 12. And then this whole side length is what? 9. Very good. We had to do it on both. So let me erase all this extra. All right, here we go. Let's set it up. 8 over 6 equals 12 over 9. Let's see if those reduce. That reduces to 2/3. Are we going to get lucky here? Oh, no. That reduces to 4/3. So, because this side was not the same scale factor, we are going to have to write these as not similar. Alrighty, that is all of the notes. I hope to goodness that when I come back, you will remember at least some of this so that we can rock and roll. I have missed you terribly. Know that I love you, and I will see you tomorrow. Bye.